Okay, fine. So let's start, and we'll start with our concept of unsupervised machine learning. Okay, so if you can recall it from your our previous discussion, our discussion was on machine learning algorithm. We very efficiently and slowly we have understood like supervised machine learning, that is, and we have seen two examples. Very frequently used example was a linear regression and a logistic regression. Okay, and we know that like what kind of data is there, and how we understand that it is supervised, and what is the differentiating factor that we need to look at. Okay, so we have historical data, so we do supervised machine learning. Okay, so now we'll talk about a situation where we don't have historical data. Okay, our data comes in a real time, or on a go it comes, and then we need to deal with it. So in that case we opt for unsupervised machine learning. Okay, and under unsupervised machine learning there are various algorithms. Okay, majorly classification algorithms comes under that. Okay, and we'll look one algorithm today, that is k-means. Okay, so k-means is like one of the machine learning, very famous machine learning algorithm, and that is used for classification. Okay, so these are the agendas that we'll look into it. Okay, cluster analysis introduction. First we'll see what is cluster, and introduction to cluster analysis. Okay, then we'll look cluster algorithm, that is we look specifically when we deep dive into codes and data, so we'll look into k-means. Okay, and then distance measures. So k-means is an algorithm. Okay, internally the back it measures distance. Okay, and basis on that it forms a cluster. So there are various techniques to measure the distance, so we look into that as well. Okay, so few of them if I want to name it, okay, are Manhattan, and then Euclidean distance. These are the very commonly used, and you might have heard about it as well. Okay, and the data preparation. So guys, so as we have seen earlier, that data preparation is one of the major portion of effort that we put in for our machine learning, before we put the data into machine learning algorithm. Okay, so same applies for supervised as well as unsupervised. Okay, so here also will involve some normalization of the data before we feed the data into a model. Okay, so that comes under data preparation part. And categorical variable is, it is as like you know it well. Okay, then evaluating clusters, profiling clusters. These are some advanced topics that we can look at. Okay, so for now let's kickstart with a very basic and like visual things that we can see in front of our screen. So cluster, what do we understand by cluster? Okay, what is cluster analysis? So if in general I talk about cluster is what? Cluster of people. If I tell you, so it means like group of people. Okay, cluster of people of different sect. If I tell you, that means there are people grouped and they're forming a cluster based on sect. Okay, let's say a cluster of people based on reason. Okay, based out of language. So the people are clustered based on the languages they speak. Okay, so that means if you see here, if I plot x and y axis, okay, in x and y axis I put on different data points. Okay, let us come to a data point, and we see there are four data points here, and there are a number of data points in middle, and there are a number and m number of data points at above that. Okay, so we can since these are closely associated with each other. Associated means like just think about distance, no other things. Okay, we'll see other features later on, but now think about distance. So since they are closer in terms of distance, so I've circled them. Okay, and then we, after circling, we see that it forms a cluster. So visually what we see is there are three clusters. So now we'll have to analyze this cluster. So you can take it in this way. You have a data points. Okay, and based on the distance, okay, how near the other data points is with it. Okay, with normal distance, that is distance formula, x minus x1 minus x2 whole square plus y1 minus y2 a whole square root over. So that is a simple distance formula. Okay, based on that we form a cluster. Fine, let's move ahead. So just read the definition: process of grouping observations of similar kinds into smaller groups within the larger population. That is it. Okay. Now move ahead. Let's take an example. We have some S1, S2 till S8. These are observations, different observations of C and V. Okay, so C is what? Chocolate. V is vanilla. Okay, if you plot this in X and Y axis, so you see there's one cluster which is getting there's a data points, okay, which is getting grouped here, and there's another data point which is getting grouped here. Okay, now if I form a circle, if I draw a circle here, okay, and then a second circle here, then I can say visually I can analyze, or I can recommend that this data set which I see in front of our screen in a tabular format is forming two clusters. Okay, and what are those? One is vanilla cluster, one is chocolate cluster. That is it. Okay, so just get the feel of what is cluster first of all, then we'll get into the deep. See, likewise we are forming a two cluster, cluster one, cluster two. Okay, now coming to clustering algorithm. So clustering algorithm, guys, I'll tell you, and you will realize it yourself once you start working in it. Okay, so K means and KNN. These are the algorithms which is, you can say, a very widely used algorithms. And specifically when you talk about classification, unsupervised machine learning, okay, this comes into rescue. Yeah. So what changes is on a in one situation you might use Euclidean distance. Okay, in other situation your result might be better with Manhattan distance. Okay, and sometimes it is with other. So the distance measure formula varies, but the algorithm remains same. Okay, so this is the algorithm you can take a note of. K-mean clustering and hierarchical clustering. Okay, hierarchical clustering. I'll come to that. Okay, first let's see the K-mean clustering. So we are all aware of a few very basic geometrical concepts of centroid. Okay, distance of centroid from any point. Okay, then square of distance. Okay, sum of square of distance. Okay, mean distance. So we are all aware of it. Okay, now k-mean clustering is based out of these concepts only. You have a centroid. So what is centroid? Centroid is the center point of something. Okay, if I see a uh, two uh, two dimensional figure, let's say x and y axis, and if I want to calculate the centroid of this, the entire data point that you see in the red dot. Okay, so centroid will obviously be somewhere here. This will be a centroid, and if I want to calculate the distance of any data point from centroid, so this will be simple distance formula. Okay, if this one is x1 y1 and this is x2 y2, then x1 minus y1 whole square plus x2 minus y2 whole square root over. This will be my distance of this data point from centroid. This all we know. Okay, and this is what is known as k-mean clustering. Okay, where k, this is, you can just like keep this as a note. Okay, k mean clustering, k stands for cluster, and many a times you will be asked this, what in if you are doing unsupervised machine learning using k means, what k stands for. So k stands for number of clusters. If your data set, you have used you have implemented any clustering algorithm and it forms 4 clusters, so your k is 4. Okay, if it is 2 clusters, your k is 2. Okay, so this k resembles number of clusters of a data point. Okay, now here if you see, so there are 3 clusters, so your k will be 3. Okay, so let's move ahead. Now this, the black dot which we saw earlier, it was red and now it is black. So what, once you run the algorithm, so in the first iteration the algorithm selects its centroid. So now this centroid is selected, this black is a centroid. Now a perpendicular, like this centroids are, I'm telling you this, you don't need to know this, but conceptually when you implement an algorithm, so if you have these concepts in your mind, so you can tune your algorithm likewise. Okay, So this is a centroid. In the first iteration, centroid gets selected. Then there's a connection. You draw a line between connecting all the centroids. So this triangle is formed because there are three centroids. Triangle is formed. Okay. Now a parallel line, if you draw, okay, which is perpendicularly bisecting the line which is connecting centroids, you divide this. So there are three lines, and this line got divided, and then each section is your cluster. So see, there are three centroids, and this particular line which we have drawn divides the entire data set into three clusters. So this is one cluster, this is two cluster, and this is third cluster. Okay, let's move ahead. So your cluster is formed, okay, with using this centroid. Now k-means does not stop here. What it actually does is, among this cluster, it will search for a centroid. Okay, and then again the same thing will happen. So it will happen in all clusters. So it's an iterative process, and it will stop only when the variance between intra-cluster is minimum. Just take a note. This is a very like deep concept. Okay, this is a continuous iteration. Centroid is selected, distance is measured, cluster is formed. Okay, once the cluster is formed, again in the next level, next iteration, another centroid will be selected, but that centroid will be specific to that cluster. In this cluster only, there will be centroid selected, and again the distance will be measured. Okay, now this process goes on. Okay, when it will stop? It will stop only when it gets the intra-cluster distance. Sorry, inter-cluster distance, and you can call it as a variance as well. Inter-cluster variance as minimum. Okay, now if I ask you what should be the best cluster, what should be the best n, who can try this? So best n means best variance, and best variance is 0. When you will get 0? No, one will not be an answer. So just try and understand this. You have first iteration selects three. Let's, if you see this as an example, first iteration selects three clusters. Okay, then again it goes in second iteration, where in a single cluster it selects centroid, again measures the distance, and if the distance is not minimum, then again that cluster splits. Okay, so splitting happens. So so what they are looking for, they are looking for a minimum variance. Minimum variance is what? 0. And when will 0 be attended? When the number of clusters is equal to number of data points. So let's say you have how much? 5, 12, and 5. 17 data points you have in this XY axis now. Okay. So if each data points forms its own cluster, so the distance between each cluster will be minimum. The variance will be 0. Okay. Based on that concept, you need to decide, you need to stop the iteration at optimum level. So you cannot ask for 0 variance. Okay, 0 variance is best, but you cannot ask for it. Okay, because 0 variance will go to an bigger number of clusters, so the bigger value of k, that is not required, that will be unstable. Okay, so what I can see it here as well. Let me, so see, this is the first iteration, again second iteration happens. So this black dot you see, this is a centroid of each cluster. Okay, that again that is getting splitted. Okay, and then the data points, this data point which was here earlier in this point I'm talking about, just see the cursor. Okay, it was in this cluster. Oh, in the second iteration, like K-mean cluster found that the variance is will be less when this data point is moved to other cluster, and automatically in the second iteration this data point is actually moved to other cluster. See here, it is moved to this cluster now, and then it found it will stop if it sees, yeah, this cluster has a less variance as compared to the other cluster. Okay, that is it. Now these are the points. Identify value of k. K is what? Number of clusters. Assign k observations as seeds from the data. So this is like you can specifically, if you know the cluster. Like if you are analyzing, let's say in case of a mail, let's again take example of Gmail, which we have seen last time. So what is the, by default, the category is inbox, then you have social, then you have promotion. Okay, so you know that if you have 10 million mails and you need to categorize mails into different clusters, so you know the value of k. Okay, it will be 3 or 4 maximum. So you can predefine the value of k, and that is in your hand. Okay, so basically the k comes from business. Okay, the people who understands the data. Okay, so that is what the second point says: assign k observation as seeds from the data. Then third point is assign each record to one. Okay, that's what we have seen. Form a cluster, calculate centroids of his cluster. Okay, assign centroids as new seeds. Okay, then if once cluster is formed in the second iteration, in each cluster one more centroid will be identified, and then clustering will be running again. Okay, so so we'll come to hierarchical clustering. Okay, first let's see one very basic example that you can do it in a system also. Okay, so we are aware of this data set iris, right? This is our iris data set. We are all aware of it. It has 150 observations. Okay, and what it is all about, it is all about flowers. Okay, species of flowers. So basically there are three species: Setosa, Virginica, and Verusa. Okay, there are three flowers species, and there are few observations. So it's a random observation. You have length, sepal width, petal width, and the species. Okay, so if I see logically, if I split, if I don't even split, if I just filter this, I run this. When I apply filters, so what I see is there are three different types of species, unique species. So if I plot it using classification algorithm, unsupervised machine learning algorithm, so it should fall into three categories. Okay, Setosa, versicolor, and virginica. Okay, now this will fall in three categories, but what will be the selection criteria, what will be the classification criteria? So classification criteria will be your length, width, and petal width. So combinedly this four observation should classify which species this flower belong to. Correct? If I give you, if you are experienced florist, okay, if you know about flowers, if I tell you, boss, this is my sepal length and this is my sepal width, this is my petal length, petal width, which category it should fall? So you should, out of your experience, you said probably it should fall in, it should be a Setosa species. Okay, likewise. So now we can do the same thing using classification algorithm. Okay, and since we are feeding the data on a real time, so we'll feed the data and we'll get the output. Okay, so that is why it is called unsupervised. So since it is a real time thing, it is unsupervised. Okay, we are not seeing any historical data based on so we are not seeing any historical data, and based on that we are not deciding which species it will be. So we are in a real time, we are feeding the data to the model, and the model is telling us, yeah, this is the species of the flower. Okay, so let's have a look, then you'll understand how it works. So this is my flower, you understand the data very well. So we have 150 observations. Okay, so what is the features? So let's what I'll do, since I'm trying to predict the species, since I'm trying to predict the species based on what? Based on the length and width. I'll assign this species as null. So I'll assign it null. Why am I assigning it null? I'll come to the value. I'll derive the value from the observations. Okay. So now if you see what I have the length, width, sepal width, petal width, but I don't have the species. Now this columns, or sorry, this rows or these observations will help me in classifying which species is this, whether it's a Setosa, it's a Virginica, or the Versicolor. Okay, clear? Are you clear with the case study, like scenario which I am creating now? Okay, you can ask me a question. We can take 2 minutes of break, and you can ask me any question if you want. Yeah. So let's move ahead, and uh, we have seen view features. So features we already have seen, and then coming to value of k. Okay, k means is, fortunately, if you use k mean, that is unsupervised, it does not need any package to be installed or like called. Okay, it comes with a default installation of R. Okay, so just type k means, question mark k means, and look for it. So what you'll get is, you'll get k-mean clustering, perform k-mean clustering on data metrics. Okay, so see what are the parameters it accepts. It accepts x, that is your data. Centers means, it means how many cluster you want to form. Okay, and it comes from business, it comes from the data understanding. So in our case, if I ask you what should be n, so what should be the answer? What will be the answer? Anyone? Any guess? Educated guess? Guys, what should be n here? N is number of clusters. Okay. So how many clusters will be formed here? Three. Great. So that's what. So it comes from the understanding of the data, and we know there are three different types of species. Okay, we have Setosa, we have versicolor, and we have virginica. Okay, there are three species. So if I give three, so when I run the model, I write k-mean, I give the data. So data without the cluster, actual cluster, then k. Okay, k is three, and then you can. It is totally in your hand. How many iteration you want to instruct your algorithm to run. Okay, so minimum, maximum. Okay, and very, like, rarely we specify the iteration. Okay, but we leave it to R and the algorithm to choose a number of iteration. That is more efficient, actually. Okay, that is what I'll do here. I'll write k means, I'll give the data set. The data set is what? This is the data set without species, and then the number of clusters k. Okay, once we give this, then we'll run this algorithm. Let it run. Okay, it is run. Now see the result. So this is the result. Now this is the result, and if we try to read the result, so we'll start from the beginning. So here, from here the result starts. Okay, this is the entire result thing. Okay, so we'll just see the important part. Okay, so important part is k-mean clustering with three clusters of size 38, 62, 50. So what does it signify? So there are three clusters formed as you have instructed to k-means. Okay, in which first cluster has 38 data points. Okay, 38 observations. Second cluster has 62 data points, and third has 50. Okay, now what will be the testing parameter? How will you evaluate that it's correct or wrong? Okay, now the simplest way to evaluate, and that is the most appropriate way, I'll tell you. Okay, that you go to the initial data that you had, that you originally had 150 observation, and in that it was already defined species. So you select anyone and compare it with the size, how many data point it has. So now, if for example, let's say third one is your 50. So if I go back to this and I filter this to, this is not the, if I see the original dataset iris, if I see this, I apply filter to virginica. So it should be how many? From 101 to 150. That means 50 observations. So that means it has 50 observations, and the algorithm correctly predicted it is 50 observation. Okay, one is having 62 and 38. So there will be a situation where you will see a mismatch. Original it is something n, and algorithm gives you n plus 2 or n minus 2. So that is the like performance measure. You measure the performance of the algorithm. Okay, or what is the bad ratio? Okay, misclassification we call it. Okay, how many data points actually got misclassified? Okay, and that gives us the percentage or the accuracy percentage of the model. Okay, that we'll see now. Fine. So this we have done. Now size. We'll come to this. This is basically size. If you run this, so you get the size of it. So you first you just type the model variable and you get entire thing. But if you want any individual thing like size, if you want cluster, so it will give you the cluster. So 3 represents versicolor something, 2 represents something, 1 represents something. Okay, now we'll come to that part, but let's understand the result. This is very important. Now what it says, it gives you the, if you form a cluster, okay, it is the distance between each cluster. Okay, this is the distance. Okay, this is cluster mean. Sorry, like if there are three clusters which was formed. Okay, so distance between each clusters or the mean distance is this. Okay, this is a clustering vector. Now this part, this is your accuracy. So your model, that is your k-mean model, is giving you accuracy of 88.4%. Okay, and this is very decent enough. Like a model giving you 88% without any data preparation. This is very good. Now let's see the, now what we'll do is we'll check the original data set that we had. We'll pull out the species. Okay, and then we'll check in the cluster that we have formed, and then we'll see what is the mismatch. Okay, and we'll do it using a table function. Table function is very efficient in measuring the performance. So let me run this. So this is called cross matrix. Okay, and how do we read it? Your one represents cluster one represents this entire cluster. Okay, two is this, and three is this. Now how will you relate it? So three is your setosa, two is your versicolor, one is virginica. You can see it like this way. Now you can ask me, it is very confusing, because how will you map it? So mapping will come from this. The moment you run results dollar cluster, or the result which you got here, okay, the sequence in which you get the numbers, 3 is coming first. So what is the first type of cluster? See here, what is the first cluster? Sorry, not this one. First is setosa. Okay, so it represents, 3 represents setosa, 2 represents versicolor, 3 represents virginica. It will be exactly in the same sequence. Okay, now that is done. Now come to cross matrix. So out of entire setosa species, everything got classified as setosa, 3 setosa. Okay, so there is zero error in this. Okay, then come to versicolor. Out of 50 versicolor, 48 got actually classified as versicolor, 2 got misclassified. Okay, 2 got classified as what? 1 is your setosa. Fine. Now out of 50 virginica, 30 got classified as virginica, 14 got classified as different species. Okay, so what is your error rate? Now if I ask you what is the error rate calculated, so your error rate will be total of this 50, 48, 36 divided by, sorry, 2 plus 14 divided by this. So that will be giving you 88 point this percent. That is how it is getting calculated. Okay, now any doubts here? In that case, you will not be able to keep in mind what is the digits. Okay, but this cross matrix will always be a savior. Okay, this is the fastest way to evaluate your model. Okay, then the second best way is plotting. You plot the original observation, and the like result observation in a graph, and then see how it looks. So see here, originally, okay, originally if I plot my ice data set, so this is one cluster, this is one cluster, this is one cluster. It automatically graph says if I plot iris data set, petal length and petal width, and what is the column? I'm giving a cluster. Okay, this is my graph. Now if I plot the result, okay, with sepal length, sepal width, so this is my cluster. Okay, we can visually say, yeah, it is right. It has rightly classified this into one cluster, this is one cluster, and this into one cluster. So this is one very efficient way to classify the, or you can say, form a cluster and evaluate result, means visually. So anything that is, if I zoom this graph, so anything here which lies here, if I give up this point, if I 1 minute, anything which, all the data points which lies here. So you can say this, there is a chance that this got misclassified because it falls in this region, this cluster. Okay, but this portion, this is 100% classifiable. This, and this has unique identity. Okay, so this also has unique identity, but this few items it's getting overlapped. So once you rerun the result 2 3 times, then you might get proper result, but in first go this is not getting classified properly. Okay, but the result is like far beyond the expectations. This is 100% classified correctly, this is classified correctly, all that. Okay. Yeah, the thing is, this hierarchical clustering is just the reverse of what we have seen, k-mean clustering. So k-mean clustering, what it does, it it takes the clusters, okay, then it tries and identifies the closest among them. Okay, but in hierarchical clustering, it takes each data point, okay, then it compares with other data points. Okay, if it is similar, it clubs them into a same cluster. Let's see this visual diagram is very like self explanatory. You have 4 clusters here initially. Okay, but then the distance between each cluster is measured. Okay, so the distance measure, guys, so if think about a situation, there's a term called features. Okay, so features is what, again getting back to our example of our Gmail. Okay, so if I ask you, if I tell like there's 10 mails and you need to classify them into different groups, so what will be the classification point? So classification point will be the content of the mail, right? So based on the content of the mail, you'll be telling, yeah, this is uh, promotional mail, this is the original important mail, this is a social mail. So what will be the content? If you have something in a mail, if you have something called comments, likes, share, so obviously that resembles uh, to a social mail. Okay, so this content which you are seeing, or on basis of what you are deciding this is a social mail, that is called features. Okay, and the distance which I'm measuring here, the circle which you are seeing, so the distance is basically measuring the features, that is calculating the features, and based on features it is, it will collaborate or it will get separated out. Okay, so see here, let's say these two cluster which are very close to each other and the feature matches. Okay, so it forms a cluster. So now instead of 4 you have 3 clusters. Okay, then again these 2 clusters, on the left side of the axis near y-axis, you see these 2 clusters are having similar features. Okay, so that will collaborate, and now you'll have ultimate result as a 2 clusters. Okay, ultimately as a 1 cluster. So the idea is, it is doing the same feature calculation, distance calculation, but in a reverse order, right? Perfect. So I hope this was clear, and we really use it. Okay, but still to have a understanding of it will help you. Now, quickly we'll look into the distances. Okay, so as I said, k-mean clustering or k-mean algorithm remains same. If I go back to R and then look for k-means, so you'll get, first search for k-mean. So here you have methods. Okay, so methods means like what distance you want to apply. Okay, then algorithm, so this all differs based on the distance. So distance is what, let's say you have two data points, so distance between this will be a simple distance formula. Okay, x1 minus x2. Okay, that formula. So this is the formula, x1 minus x2 whole square plus y1 minus y2 whole square root over. So this is the distance. So now this, what will be the distance between two clusters? Okay, it will be a distance, similar distance, the same distance which we calculated, but the distance between two centroids of two different clusters. Okay, based on that we calculate the distance. Okay, similarly if there are three clusters, so distance between three centroids of the cluster. So if I want to calculate the distance here, so my, let's say this is a centroid. Okay, this is a centroid, and here this is a centroid. This is a centroid. So what will be the average distance of this this three cluster? So it will be distance of this, distance of this, and distance of this. Okay, fine. So let's move ahead. Yeah, so that's what it is calculating, distance. Fine. So just a quick recap: distance measured between 2 points. Okay, distance measures between 2 points. Distance measured between two clusters. Distance measures between a point and a cluster. Okay, and the formula is same. Okay, now we'll think of a situation, okay, where we'll recall our old discussion that we had. Okay, uh, we had a data set, and then we found salary value to be very high as compared to other uh, variables like age or any other variable. Salary was very high in terms of magnitude, I'm telling you. Okay, so the same case can be applicable here as well. So I'll try and share this. Let's say you have x and y axis, and you have three columns. You are getting three columns. One column represents salary, one column represents phone number, and one column represents your let's say some ID. Okay, now salary, phone number will obviously, if I consider that as a integer, and it will be always like, if in case we belong to, like we are in India, we have 10 digits of phone number. Okay, so 10 digits of number will be huge in magnitude if I plot them in xy axis. So obviously it will be, let's say, somewhere here. Just think it like the thing which I'm telling, just try to analyze it. Okay, it will be somewhere here. This is a phone number. Okay, now the second column is my salary will always be in 3 or 4 digit, 5 digit maximum. So if I plot in this scale, in the same scale which I have plotted phone number, so it will be somewhere here, very like far below or away from the phone number. Okay, then if we plot some other like numbers, it will be here. So what we see is the distance between these two cluster does not make any sense. Why does it not make any sense? Because this two, it represents something else, This represents something else. Okay, let's forget about this. Let's leave this for now. Okay, and you'll get some distance here, and the algorithms gives you some distance which actually makes no sense. Okay, because what will you do with this distance? Because as this is two different things. Okay, so in order to avoid such scenarios where you have columns, one of different magnitude representing different things and another with different magnitude representing different things, so we go for normalizing the data set. Okay, we normalize and bring all the columns into the same scale. Okay, like as we did in case of linear regression and logistic regression, we do this we do the same thing here as well. Okay, so we do normalization a lot. Okay, fine, let's go ahead. So that comes under data preparation part. Okay, you do scaling and weighting. So if you feel like there are some data points which is weighing very less as compared to other point, so you scale it. Okay, and then if you find some data point which is huge in terms of other data point, then you weight it and bring it less, but bring it low in terms of magnitude. Okay, so just read it. Concept of adjusting the value of variable to take into account the fact that different variables are measured on a very different scales. That is called scaling. Guys, are you clear with this concept of scaling? Okay, see a good example here. Number of children and income. There are two variables. One is number of children, which will always be 1, 2, 3. A person cannot produce 500 children. Okay, so and it cannot go more than single digit. Yeah, sure. So a good example is here. You Let's talk about this is again a data preparation. Okay, in data preparation you have scaling. Scaling is what you scale the data column to extent where you bring them into a same label. Okay, so let's say number of children is one value which has 3030 as value, and then you have person whose number of children is given and income is given. So if you plot this number of children and income in the same scale, so they will have a huge variance. Okay, so what we do is you do there's no hard and fast rule that you will have to follow this. Okay, you can do anything that can normalize it, that can bring the value into a same scale. Okay, see here, it forms a cluster. Okay, there are multiple clusters. So what we did is like you either take a standard deviation or you take a what I generally do is I'll tell you what I generally do is I if something like this occurs to me, so I take, let's say I'm normalizing this income. What I'll do is maximum of income, let's say minus minimum of income. Okay, divide by maximum of income. Okay, I'll get some value. I'll multiply this. I'll multiply this with the entire income, and I'll get some normalized value. Okay, clear? This is a good example to look at. Okay, perfect. So this is data preparation, and it's you'll be using it a lot. Okay, and this is, as I said, you since there is no hard and fast rule, so it is very easy. You can do anything as whatever you feel like to make the data normalize. Okay. Okay. Now methods of scaling: divide each variable by a range after subtracting the lowest. So that's what I did: maximum minus minimum by maximum. Okay. So it will obviously if the value is 10,000, minimum value is 10,000, maximum value is 20,000. So difference will be 10,000 divided by 20,000. So we'll get 2 or zero point 0.2. So obviously it came into a range of that 3 children, zero point 0.2 income. Okay, so it will come to a same range, and this is very commonly used method of scaling. I'll share the slide. You can have a look. Now weighing. What we do in weighting, concept of adjusting the value of the variable as per their relative importance. Now, if let's say you in weighting, like again we take the same example of uh, like income. So in that case, what we'll do is we'll drive any constant value and we'll multiply like any random value, zero point 0.2, zero point 0.3, and you multiply the entire thing with that constant value. Okay. Okay, so weighing is nothing but taking out a constant value and then adjusting it accordingly, multiplying it with other thing. Fine. So I guess that is it. I'll share the slides and the code of k-means. You go through it once, okay, and if you have any doubts, we can discuss it ahead.